Okay, so let's look at another example. Okay, so here's another theorem. So let A sub I and B sub I be sequences. Then if I turn these into series, so the sum from I equals m to n, right, just sum bound of A sub I plus B sub I, okay, that's equal to the sum from I equals m to n of just A sub I plus the sum from I equals m to n of the B sub I. Okay, that seems like it should be the case, right? And so I'm going to again start by giving you an informal or a ... proof. So if I have this, what I really have is A sub m plus B sub m plus A sub m plus 1 plus B sub m plus 1 plus ... plus A sub n plus B sub n. Okay, and now I'm just going to rearrange this by moving all of the a's to the front. And then all of the b's. And of course, this, I just have a notation for that, right? And remember that this is just a notation. This is just a way of being able to write that expression, okay? And again, I have a notation for the b's. And that's exactly what I wanted to show, okay? So that's the informal proof, okay? Again, this is not a formal proof, and in particular, if there were an infinite number of values in the ... then it wouldn't work, because with an infinite sums, you can't actually rearrange things. Sometimes you get different results. So, so it is an informal proof, okay? But I can make it formal by using induction. Okay, so let's do this by induction. The base case. So the base case is when m is actually equal to n, okay? And in that case, what we have is that the sum from I equals m to n of A sub I plus B sub I is actually the same as the sum from I equals m to m of A sub I plus B sub I, because m is equal to n, and that is just A sub m plus B sub m, okay? And then that happens to be equal to the sum from I equals m to m of A sub I plus the sum from I equals m to m of B sub I, okay? So that's the base case, okay? And as often is the case, you know, the base case is just a matter of checking, okay? So let's start the induction step. So here's our induction step. And what I'll do is I'll say that, again, n is greater than m, okay? So we have the sum from I equals m to n of A sub I plus B sub I, and that's equal to the sum from I equals m to n minus 1, that's where I'm using the fact that n is bigger than m, plus the very last term, which is just A sub n plus B sub n, okay? And now by induction, okay, this is where we use the induction hypothesis. This is equal to the sum from I equals m to n minus 1 of A sub I plus the sum from I equals m to n minus 1 of B sub I plus A sub n plus B sub n. Now notice I only have 4 numbers here that I'm adding, so I can actually rearrange them at will, and I get the sum from I equals n minus 1 of A sub I plus A sub n plus the sum from I equals m to n minus 1 of B sub I plus B sub n, and of course that's just equal to the sum from I equals m to n of A sub I plus the sum from I equals m to n of B sub I. So we're done. It's QD. Okay, so this is another kind of simple properties about series that we can prove by induction.